Right, so here's a different kind of word problem. We got a physics-based word problem here. And, sorry, left that off the screen. Time for free fall. The formula s equals 16t squared is used to approximate the distance s in feet that an object falls freely from rest in t seconds. So we drop something, and after t seconds, it will have dropped s feet. And you don't need to know where this comes from. This is just something that happens to be true on Earth, ignoring, of course, wind resistance and stuff like that. Ideal situation. So our distance is equal to 16 times however many seconds have passed squared. The Taipei Tower, blah, 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 is 1,670 feet tall. How long would it take for an object dropped from the top to reach the ground? And then I'm not going to come back to the book here, but the Gateway Arch in St. Louis is 630 feet. Same question, how long would it take an object dropped from the top to reach the ground? Let's get back over to paper here. Okay, so we got that Taipei Tower, 1,670 feet tall, and we're wanting to know how long it would take something dropped from the top to fall all the way to the ground. Well, it's pretty simple. We've got our function here, which is s equals 16t squared. All you have to remember is s is feet, t is seconds. So if you're given a distance and asked to find a time, you put the distance in for s. So we get 1670 equals 16t squared. And it's pretty easy to solve. You just divide 1670 by 16 and you get about 104.375 equals t squared. Right? Just divided both sides by 16. And then to get rid of the squared, we just do the square root. And the square root of 104 is about 10.2. I'm not doing that in my head. I did it previously on the calculator that I'm looking at over here. So it would take about 10.2 seconds. You may or may not, in my math, I'd be asked to put the units on these again. So it'd take about 10 seconds to fall all the way from the top of maybe the highest building in the world, I'm not sure, to the ground. How about from the top of the arch? The arch is only 630 feet, so it shouldn't take quite as long. And I think most of you, if you are somebody who's in my class, you probably have seen the arch and have a good sense for how tall it is. We got a distance again, so we put that in for s. Divide both sides by 16, and that'll give us 39.4, give or take, and that's t squared. And then we take the square root, and we get about 6.3. And we know that's in seconds. Does that seem reasonable? That if you drop something from the top of the arch, it would take about 6 seconds to land? That seems pretty reasonable to me. It's a pretty tall arch. There's none in my math lab that are going to ask you this, but I think it makes sense to look at this from both ways. What if we are given a time? What if we're asked, if we drop something from a tall tower or whatnot, how far will it fall after 3 seconds? Or how far will it have fallen after 3 seconds? Well, that's a time. And time is t. So if we put 3 in for t, we'll get s is equal to 16 times 3 squared. In the order of operations, exponents come first. Well, they don't come first, parentheses do, but they come before multiplication. So we wouldn't multiply 16 times 3. We do 3 squared first, and we get 16 times 9. And if I'm not mistaken, 16 times 9 is 144. I'm going to check that. I'm not mistaken. It is 144 feet that something would fall in 3 seconds. How about 20 seconds? The distance then would be 16 times 20 squared. 20 squared is 400, and 16 times 400 is 6,400 feet, which if you live in the American system, you know that a mile is 5,280 feet. So in 20 seconds, whatever this is, would have fallen more than a mile, which actually isn't true because wind resistance and whatnot would kick in and slow it down. But given the simple version of this formula that we have, it would be the truth.